Hi, everyone. I'm Muriel Medard, co-founder of Optimum and also CEO. And welcome back to my board. I've made a little bit more space than last time to continue talking about coding. So last time we looked at the simplest setting where we had three numbers, x1, x2, x3, and we were sending them from one node to another. And we were trying to make up for the problems that could arise from losing some of these numbers. Okay. Now, this is not really a network, or it's just it's just a single link network. It's not what we would consider really to be a network. So let's look at the simplest version of a network, which is at least having two links rather than a single link. So let me look at this very simple version where I have a transmitter here, node 1, a relay, node 2, and a last node, node 3. And we're going to see what happens in this system. Okay, so we know about coding now. We know that coding is about generating equations. And we have our old friends, x1, x2, x3. We're trying to get them from the transmitter all the way here to the receiver. Okay, what do we do? Well, assume for the time being that I end up losing one of the numbers on the first link and also one of the numbers on the second link. But of course, we don't know which number will get lost. And as an example, let's say that I send x1, x2, x3 over to node 2, and that the second number gets lost. And node 2 is just a dumb relay. It's just sending along what it received. And so it sends then these three numbers that it got, x1, x3, because it missed x2, and the sum of the x's. And it sends it over to the receiver, and another number gets lost along this 2 to 3 link, say that it's x3 that gets lost. We end up here with three unknowns, x1, x2, and x3, but only two equations. And so node 3 is not able to decode. Now, what we could do is have the transmitter say, well, there's going to be two losses total, one here, one there. I should really add two equations rather than a single equations. We could come up with another equation, say x1 plus 2x2 plus 3x3, any other, a lot of other equations will do. And that way, this node 1 here would have to do 5 transmissions. They would be then 4 received equations, and then node 2 would say 4 transmissions, and they would be 3 received equations. Okay. So that would cost me basically 5 transmissions and 4 transmissions for a total of 9 transmissions. Now, could I have better utilization, so somehow end up recovering all of the data without doing that many transmissions? Well, I could. In particular, what I could ask the middle node to do, node 2, is to do something maybe a little smarter. I could say, well, look, why don't you decode from the transmitter? You have x1, you have x3, you have the sum of x1 and x2 and x3. You could reconstruct x2, decode, and then by reconstructing, you would now have x1, x2, x3, and now you can decode, recode, now send, and that would cost me, so here I would have 4 transmissions. Now I would have again 4 transmissions, and I would have maybe this time it was, if you recall, x3 that got lost, okay? And if x3 gets lost this time, I still have 3 unknowns, 3 equations. I can reconstruct x3 from x1, x2, and this and the sum. Okay, so now rather than having a total of having to have 5 and 4, which remember before it cost me 9 units of transmission, now it's costing me just 8 units of transmission. Okay, so I got a better efficiency in my network. I didn't have to pay as much in terms of transmissions, and so I got a better throughput by not having to do that. Okay. So you would say, all right, that's not so bad. Maybe that's what I should do. Ask the middle node to decode. And by asking the middle node to decode, in order to get the three numbers, x1, x2, x3, from 1 to 3, the total cost of the network is 8 transmissions rather than 9 transmissions. This is basically the throughput, right? Throughput is you're trying to send as few transmissions as possible in the network in order to recover the 3 numbers that you wanted to recover. The problem here is we've talked about number of transmissions, but what about time? Here I have to send 4 numbers, which in terms of time is going to cost me 4 units of time. And then I have to get all 4 numbers. Obviously one of them is missing, but I have to wait for 4 time slots, okay? So 4 time slots here, and then I'm going to have to do that again. So 4 time slots plus 4 time slots, it's for a total of 8 time slots. So I'm going to put squares around the time. This is time. So this is number of transmissions, and this is total time. It costs me 8 transmissions and 8 units of time. All right? What if I do something different? What if I transmit and I don't decode, but I simply recode? So this is what's going to happen. Now, what happens if the middle node doesn't just do dumb forwarding, which needed more total transmissions, doesn't do decoding and recoding, which requires a lot of time, but actually does randomly network coding? Let's work through this example. So at time 1 over here up top, I'm showing what I'm transmitting on the link on the bottom right above this. So I transmit x1 from 1 to 2. 2 has nothing to transmit, so it's blank. At time 2, I transmit 2, x2 from 1 to 2. And 2 now has x1 to transmit. At time 3, I transmit x3. Now recall that in our example, 2 got lost in going from 1 to 2, so it actually didn't make it. And therefore, in the link from 2 to 3, node 2 only has x1 to transmit because the second transmission had been lost in our example. Now, at time 4, the transmitter 1 transmits the sum x1, x2, x3 to node 2. And what is the link from 2 to 3 going to transmit? Well, the link from 2 to 3 at this point has 2 numbers. It has x1 and it has x3. Maybe it goes ahead and sends x1 plus 2x3. Okay. Time 5, transmitter is not going to transmit anything anymore here. What are we going to transmit from 2 to 3? Well, let's see what 2 has available at this point. It has received x1. It did not receive x2. It has received x3. And it has received the sum x1 plus x2 plus x3. Okay. So maybe what it does is it goes ahead and sends another equation, say 2x1 plus x2. So it adds x1 here to this equation, plus maybe 3x3. Okay, so that's the equation. And what it did is it added 2x3 to this equation here at the bottom, 1x1, and it got to 2x1 plus 2x3 plus 3x3. So now, what does the receiver have? Remember that our receiver basically was losing the third transmission from 2 to 3. So in this case, the third transmission from 2 to 3 would have been the third time slot. So the third time slot was this one. Okay, so not the third transmission, but the third time slot. So the third time slot was basically x1, this extra x1 got lost. So now the receiver has x1 plus 2x3, it's able to recover x3. Now it knows x1 and x3 is able to recover x2 with the last equation. So how many time slots did we have? Well, we had a total now of just 5 time slots. How many transmissions did we have? Well, the first link did 4 transmissions, and the second link did 4 transmissions. They overlap everywhere except at the beginning and at the end, where at the end, the first link ceases to transmit, and at the beginning, the second link doesn't start transmitting. So they're basically pipeline. That's what we call pipeline. So what do we have? We have a delay of 5. And how many total transmissions did it cost me? Well, it actually cost me just 4 over here and 4 over there. So same number of transmissions as if I was encoding, decoding, encoding, decoding, but massively lower number of time slots. So this is why doing recoding at the intermediate node gives you a actually provable optimum throughput. That's the same most efficient use of total number of transmissions for the numbers that got actually received, and gives you this massively lower delay than doing encoding and decoding. So if you want to have both throughput and low delay, low latency, this is why you need to use recoding.